So I'm a consultant and data scientist with Atos, and this presentation is going to be a game of two halves, with really showing the two halves of my role. And I understand that we do have quite a lot of depth of data science knowledge here. I'd just like to have a raise of hands. Who here are Python users? Okay, that's excellent. And R users? That's sad. Personally, my weapon of choice is R, but I do enjoy Python as well. And to clear up what we're talking about, we were talking about KNIME earlier, and it's worth noting that KNIME has nodes for R and Python, so it's got all of the power of both of those languages within it, even before you start looking at all of the nodes which are actually part of the KNIME workflow. So it's just enormous. It's enormously powerful. So to crack on with the first half of my talk, this is the consulting side. And so as data professionals, I'm sure that you've heard this kind of thing, that you're the guru, you're the wizard, you're the unicorn. And that's very nice, it's very flattering, but it's also kind of dangerous. It's quite naive to be seen by your company as quite so special, because what it does is it really isolates you, and it means that other people who would be available to help perhaps don't feel confident enough. So I'm sure everyone here thinks that they're very approachable and people can come to them with data questions, and you can have discussions. And okay, so you might be at the top of a mountain, but it's quite nice to get there. From the other side, people often think that actually it's very daunting to come and see you because perhaps their question is really easy, perhaps they're being stupid, perhaps they don't have the right data to answer their question. And so it means that you've got all of these questions which may never get asked, which represent real business value. So what we like about KNIME is that it helps to level this mountain. So sticking with my mountains, we all know that 80% of the work is really getting the data together and getting in a position where we can actually start to apply the models. And I always think of it as the fun bit, that last 20%, because you get to really run competitions and see which model behaves the best, and then tweak it and see if you can eke a few more percentage of accuracy or improve the precision and recall. That 80%, there's not really much value that you're generating at that point when you're doing your data cleaning, your feature engineering. It's all preparation for that last bit where we really do add the value. So what would be good is if we could actually farm off some of that 80%. And the reasons that we often get approached and people throw data over the fence at us are these, that people don't think that they're capable enough, or they say that they're not, even though they know that they are, but it's quite hard to defend against. They may feel that they don't have the right tooling, etc. I'd say that here, these two are quite valid excuses, that we are the experts, so there are some things which we definitely are best to handle, but that doesn't mean 100% of the mountain should be ours. An awful lot of it is addressable to people who use Excel, who generate the data, who work with the data, and it's likely that in fact they're best to actually deal with it. Who is going to know which features are most likely to be important than the people who work with the data day in, day out? We can come in and we can look at the data and we can understand what's most likely to work from perspective of models, but from actually understanding and the real subject matter expertise of that data, you want that as low down as possible. So we're stuck being the expert, but with a tool like KNIME, the excuse of I don't have the tools should start to disappear, and we need to be partly responsible for making that happen. So coming back to R and Python, I think anyone here who uses them really does enjoy and get a kick out of creating a script that runs through and produces exactly what you want. and comes out with some nice visualizations as well as predictions at the end. However, I think we'll all agree, especially those who didn't come from a computer science background, that actually learning it was pretty rough. And if you ever talk to someone in the business, they can be very reluctant to actually pick it up and start using it. In fact, just today, I was talking to a client, and it was in the context of KNIME, and he said, oh yeah, I got that installed, never used it, never planned to use it. Tough crowd. We were able to actually show KNIME in this context, and he was really interested in it because he could actually see the elements in it and could see how he could use it to work. But at the same time, they do have a data science function in their organisation. So we were able to say, look, if there is anything that you do struggle with, then you can contact them and they will give you this node, which will be a black box, which will take your data in and it will spit it out in the way that you define from them. And that was good enough for him. He doesn't have to use R, but within KNIME, he's got all the power of it. So this is the model that we tend to look towards for increasing data science maturity. So on the left-hand side, you've got kind of the status quo, that you'll have isolated departments who will have their data stars, their Excel gurus, etc. And those will be your people that you want to talk to and influence. So they may not be up to your standard of knowing how to create statistical models and work with large quantities of data, but they're interested. It's a place to start. And so what you can do is you can start working with them, upskilling them, work with some projects with them to actually get some business benefit. And once you start to get a community and a bit of momentum, then we find that people want to do this more and more. And then you've got the potential to create a centre of excellence, which then has the opportunity to get formalised by senior management. You can actually change your target operating model to reflect this. So at the top, you'll be looking at your chief data officer, and this will be a semi-autonomous group within his function. And what we're looking at here on the right is the fact that you've got people who can actually move in and out of it. The idea is it's going to be porous. It's going to be a porous structure. So you'll have a core team, but then you'll have your, some people call them citizen data scientists. So the people who are quite enthusiastic from the rest of the organisation. They can come and they can join for occasional projects and then they'll leave. You can get people who perhaps aren't data people but have got some real expertise. They can join for a short time for a project and hopefully come out as enthusiasts. And with this kind of model, we've seen that we can derive some very substantial business benefits. So when talking to those people who are the very isolated pockets, you've got to give them something. So sure, they are quite flattered that they are seen within their small pond as the big fish, that they can work with Excel, they know about VLOOKUPs. That's a great start, but they often want to do more. Perhaps they've moved on to work with macros, and we see that some organisations massively overuse macros, that they turn Excel into all sorts of hideous Frankenstein monsters. So what we can offer them is some automation, that by using KNIME, that they can create their weekly, monthly reports at a push of a button rather than take 3-4 hours. And this becomes a virtuous circle, that they get more time to invest in actually learning more skills, and then they can find more things which can be applied, and then they get more time, etc., etc. And also, they'll get deeper skills. So you start to really get some curiosity going, and that's when you get people from moving from good at Excel to citizen data scientists to data scientists, and that's really what you want to see. And the payoff for us is that we can get some cleaner engineered data that once we've given them a tool like KNIME, then they can actually clean the data themselves, and we can actually define, we want to see the data in this kind of format, and have a think about yourself. What kind of features would be really useful? Perhaps you should subtract date X from date Y to give us the range, etc. And so you can build up the thinking behind it. This is an example from a client that I've had in the past month, that they outsource some very large surveys. It's once a half. And this survey company then returns the results in two formats. One in Excel for the senior management of the organisation, and one for the 2 or 3 people who have SPSS, who can then do things with it. What we've done is we've given KNIME to everyone that would possibly say yes to it. And this was including one of the senior managers. And with about 3 lines of our code within one node, we were able to import the SPSS data for that person. They went away, they were a bit curious, and they decided that as a bit of an exercise, they'd compare it against the Excel data. And they found some disparities. So exactly the same surveys were being reported in 2 slightly different ways to these 2 levels of the organisation. So now we're going to be diving a bit deeper to see exactly why those disparities have occurred. And I think the survey company might have some questions to answer. And so this is just an example of if you give people data or give people access to tools to process data at a relatively low level, they'll just start working and do exactly what you want. They'll explore, they'll work with data, and they'll come up with interesting things which you would never have compared. So, as data specialists, what I'd like you to come away from this part of the talk with is that there are people out there within your organizations who are languishing with Excel and need your help, and they would very much like some help with some tooling. We think KNIME is fantastic. We've conducted market analysis and we chose to be partners with KNIME. As Atos, we are actually vendor agnostic, but I think the fact that we've chosen to work with KNIME speaks volumes. And so maybe if you are a Python shop, then if that's all that you are willing to work with, then give people Python, teach people some Python. But if you can give them more accessible tools, and KNIME is fantastic that you get everything for free. It's not limited by capacity like some are, or it's not limited by capability like others are. Everything is free and ready to use in their desktop edition. Once people start using KNIME, then they won't stop. We see that people just get interested. It's their day-to-day job, and people want to do their jobs well, generally. And so what they'll do is they'll dive into data because they're interested in it. It's what they do. It's part of what defines them. So first step is always to start with automation. That is what's going to save them time. That's what they're going to be interested in at the outset. They do want to do their jobs better, but to be honest, to start with, they probably want just a bit less on their plate. So if they could actually automate some reporting, etc., then very soon they're going to be your best friends. Work to building a community. So once you've got 2 or 3 people who are quite interested in data generally, but potentially just processing their data, get them together, get them talking, get some ideas flowing. If you've got groups such as Microsoft Teams, for example, start a team, have regular meetups, so sort of every Tuesday after work, just 10-15 minutes, catch up on what you've done, how it's worked, and just get some momentum going. And then eventually look to get senior management buy-in to start to formalize the community. And eventually that creates the opportunity for organizational change. And so this will mean that we'll have formalized structures in place and perhaps a center of excellence, which means that people have a single source of truth, a single place to go with their data queries. So it's not just a case of knowing Pete from analytics, it's that there is this function that is there to support them and there to help them. So that's part one. Part two is a bit more hands-on and fun. So this has come from a personal project that I was just interested to see whether it was possible to integrate KNIME with a 3D program to create 3D visualizations. So this will be a walkthrough of the proof of concept and an introduction to using KNIME as a front end. I do use a 3D map as the example. I'm not advocating that this is a really good way to show data. Anyone who's interested in the ratio of ink to information, I do apologize in advance. This was just because I had my hands on some useful maps at the time. So, exactly, why did I use the maps? Ordnance Survey is a fantastic source. They provide shapefiles with a lot of detail attached. Obviously, for showing to people within my company and clients, everyone knows what a map is. I wouldn't have to build a model and then explain that this is a specific type of pump and sort of these sprockets can get hot or something. A map is a map is a map. So, first challenge was to get shapefile into Blender and then to start to actually see if I can change some of the different features on there. So what is Blender? For you, so it's an open source 3D tool that has been used to create several quite long animations of sort of 15 minutes, but it's used mainly for 3D modeling and less so in visualization to date. But I think this is changing, that you do see some specific applications around the use of medical data. So there's a lot of work using MRI scans and being able to build 3D models of brains from that and other organs. So I'll just flip over into a version of Blender. So obviously this is all on my laptop, which doesn't have a GPU and is rather aged. So please excuse any slight slowdown. So here I've got a map of Great Britain, and I've set up 3 cameras around it, so top and both sides. And these objects here are lights. So if I change to a rendered view, I've also set up the materials so that based on the height, they change color. So this is an attribute that I could get to change from within KNIME, but since it's something that you can actually set within Blender, it just makes sense to do it here. So my objective was to see whether I could get KNIME to communicate with Blender so that it would automatically set the height of these different regions to give me my 3D map. So this was the overall workflow. Take shapefile data from Ordnance Survey. With R, I did some simplification of the shapefiles because they're incredibly detailed, and generally you want to work with as little geometry as possible when you're working with 3D, just because of the computational power involved. So I refined those shapes within R. I changed the format to SVG rather than shapefiles while maintaining the names of each shape, which then allow me to marry up any data which I generated within KNIME to actually be displayed within Blender. To take a further step back, effectively what I was doing was I was using KNIME to generate a JSON file, and then using Python within Blender to read the JSON file and set the various attributes. So KNIME is completely a front end in this case. It's user-friendly, and you saw from the previous demonstration that you can set up workflows which need absolutely no data science knowledge. You can just have a series of slides, etc. So that's just generating the JSON, which is then fed in and read. So this is the workflow that I used. So effectively what's happening here is it's reading the shapefile, and then it's extracting the various regions from that shapefile and attaching some random data. Then it's writing out the JSON file, and then these nodes here actually open up a version of Blender each with a script to render each of those cameras. So it does those three in parallel. The reason for the meta node at the top, sorry, not meta node, the control variable at the top, which feeds into these three, isn't that those nodes actually require data from there. It's just for a timing issue, that I don't want these to start reading data before it's actually been written, because there's a risk that it would use an old version of the file. So that just ensures that I get the right sequence of events. So this is within KNIME now. So I think this will take about a minute, because, as I said, this is a laptop that isn't exactly designed for the purpose, because laptops aren't really well known for their 3D rendering capabilities. The good thing is that you couldn't have actually have done this at all about a year ago. This is using the new version of Blender that's got a new render engine called Eevee, which is effectively a games rendering engine. So generally, when you think about this type of setup, you'll be using a 3D ray tracer, which maps every point of light and sees how it bounces around your screen. Things like game rendering engines take a lot of shortcuts. So this means that this will happen in a minute rather than about 3 hours. Of course, I'm not sure it'd take 3 hours. I think my laptop would probably catch fire or something in the meantime. So what we'll get very shortly are some outputs. So for the while we wait for those, the key lines for this really, for KNIME Python users, are these ones here. So it's not that difficult to actually send data out and create your to create your JSON file. Oh, hello, here we go. So the real trick was actually bringing these back in to the KNIME environment. And so those buffer lines, what they're doing is they're reading these files from the temporary source, which I saved them to, and then reading it into the buffer, and then supplying it to KNIME to actually visualize. And that means that you do get seamless integration, that you never see Blender running as you saw. They just appear. And on the computer that I actually developed this on, they appeared in about 3 seconds. So on a proper computer, this is very reasonable return time. And I can just set this going again while I talk. So I'll just change this random variable. So this is going to change the heights. And I'll run these 3 again. Come on. And I'll flip back. Okay, so while we wait for those others, so this is just a proof of concept. Like I said before, this the aim of the game was not to create some attractive 3D maps that then I'd go out to the world with and show. The reason for doing this is to show that we can actually manipulate attributes of a 3D model. And this is useful going forward for things like a digital twin or augmented reality, where potentially we could do something like create a 3D model of something like a jet engine, and we could show the degradation over time of the various parts, where you actually need to see how each part relates to another in a 3D environment. So for those reasons, it's not just a gimmick, it is actually very useful to be able to do, but also we can see that more generally it's possible to use KNIME as a front end with open source pieces of software which tend to be based, or at least have an interface with Python. So we can actually do something interesting within KNIME, either just create some variables or do some proper data science, and then have an extra step to actually visualize them. And just to show you, you have got a separate set of views. So that is the end of my presentation. So thank you very much, and of course, Blender.